All right, so we are going to look at section 1.2, function operations. So this is dealing with anything like adding two functions, subtracting two functions, multiplying, and then dividing. So we're going to go one by one here. First thing we need to look at is how to add functions. So for the function f is defined by 2x squared minus 3x. So evaluate each of these. So in this problem, it gives us an f of x plus f of 3. So remembering what we did last section, whenever we have something like f of 3, that means we're taking 3 and we're plugging it into the function. So we're going to write it accordingly. So f of x. So all I want to do is grab f of x and write f of x. So that is the 2x squared minus 3x. And then plus, so we're adding another function evaluated at 3. Well, same function, but evaluated at 3. So we're taking our function and we're plugging 3 in to all the x's. Now that we've done that, now we can simplify like we were doing in section 1. So 3 squared we know is 9, and then multiply by 2, so we're going to get 18 there. Minus 3 times 3, that'd be minus 9. And then these first two drop down, first two terms. And then we just simplify the 18 minus 9, and we get a final answer, which would be equivalent to the beginning problem, the f of x plus f of 3. So 2x squared minus 3x, and then 18 minus 9 would be 9. So this is the new function. We go to part B, f of negative x. So instead of f of x, it's f of negative x. So all we're doing is taking all of our x values and we are changing them to negative signs. So remember, anytime you're dealing with a negative, we are going to put parentheses. So we have 2 in parentheses. We're going to put that negative x squared minus 3 times negative x. Now we can simplify. So we have negative x squared. We know that's going to be just x squared. So we have 2x squared. And then negative 3 times negative x. That's going to give us a positive 3x. And there's no more simplifying to do. That is our new function. So we leave it as is. That's our answer. Next one, we are substituting 3x into the x's. So we're going to write those. So 2 times the quantity of 3x. And then we got to square that. Minus 3 times 3x. Now we can simplify here. So 3x squared would be 3x times 3x is 9x squared times 2. That's going to give us 18x squared. And then negative 3 times 3x, we know that is going to be negative 9x. So there's our final answer. Now we have f of x plus 3. So we're doing the same exact thing. It's just slightly different because we have an operator in there too, the addition. But we're going to start it off the same way. We're going to take our x and we're going to replace it with parentheses and we're going to stick this inside where x was. So x plus 3 goes in here. We have a squared on there. And then we still have this negative 3x that we have to deal with. So we're taking x plus 3 there as well. And now we have to simplify. So this is where we have to remember how to multiply two binomials together. So remember this right here, x plus 3. We don't just want to square the x into 3 and then have that be our answer. We need to remember that this is x plus 3 times x plus 3. I'm actually going to write that out as a step so we can see it. Most of the time you're going to skip this, but I just want to make sure we are all on the same page. That's what that really means. Anytime you square a number, it's that number multiplied by itself. And then the negative 3 times x plus 3, we can go ahead and distribute that in. So negative 3 times x, and then negative 3 times 3 would be negative 9. Now we have to deal with the two binomials being multiplied. So remember, we take this x and we multiply it to the x. And this 2 stays outside. So whatever we get as an answer is going to go in parentheses. So x times x is x squared. X times 3, that's going to be a positive 3x. And then this 3 times this x would be another positive 3x. And then 3 times 3 would be 9. So this parenthesis is just from multiplying these two binomials. So we have to still bring this down on the outside. So negative 3x minus 9. So now we can go ahead and distribute the 2 in, but keep in mind, so we have this here, 3x plus 3x, we know that's going to end up being 6x. So when we multiply the 2 in, let's just keep that in mind. We'll skip a step there. So 2 times x squared, and then 2 times the 6x, so that's going to be 12x. And then 2 minus the 9, that'd be 2 times the positive 9 would be positive 18. And then we still have this stuff we need to drop down. So now we can combine like terms and simplify and be done. So there's only one squared term. 12x minus 3x, that would give us a positive 9x. And then 18 minus 9, that'd be a positive 9. So that's your first look at some operations. So subbing in, evaluating like we did before, and then adding functions. So just take a quick look at this. This is all the operations and some examples in function notation of addition, subtraction, multiplication, and division. And we can go over those again in class. So looking at example 2. So given that f is this function and g is this function, we need to be able to add functions and subtract functions. So this right here, this f plus g of x, that's how you say it. This means I want to add these together. So if you look up in the table, there's two different ways that you're going to see this written. The way that it's written here, and then the f of x plus g of x. It means the same thing. So now what we're going to do is we're going to take this function f, because that's what is given first. So we're going to write f and then we're adding, so I'm just going to put an addition there, and then we're adding g. So we take all the terms of g and we add them. So basically what we're doing is when we're adding two functions together, we are just combining them like terms of the two functions. So there's only one squared term, so we get 2x squared. 4x and 2x, so that's going to be a 6x. Negative 6 minus 2, that is a negative 8. And this is our answer. Moving on to subtraction, f minus g. So again, order is super important in here because of the subtraction. It doesn't really matter a whole lot for addition, but it's nice just to keep in the same state. So we have f. So we're going to write, again, we're going to write f as it stands. So 2x squared plus 4x minus 6. Now I am subtracting g, so I'm going to subtract. So you can do one of two things here. When you subtract a function, you can change all of the signs of that second function and just write them. What I'm going to do is, just so everybody's on the same page, I'm going to put the second function in parentheses. So 2x minus 2 will go inside. Either way you do it, you're going to get the same thing. Because when we distribute this negative into all the terms inside, that's going to become negative 2x and then a plus 2, like it would have if you switched them right off the get. So we have 2x squared. We can skip a step here. So we have 4x, and like we said, we have a minus 2x. So that's going to end up being a positive 2x. And then negative 6 minus negative 2. So remember we said that was going to turn into a plus 2. So negative 6 plus 2 is negative 4. And then that is our answer. So moving on to the next page. So pause this and do the 2 checkpoints, and then I will show you how to do them. So looking at these two functions, we have f plus g. So I just have these two, and I'm going to skip the first step that I did in the examples just to save some of your time. F plus g, all we're doing, like I said, is combining like terms when we're adding two functions together. So I look in function f and function g at the same time, and I go high to low as far as the exponents go. I always start with the biggest. So x squared is the biggest. There's no squared term in the f, so I'm just going to write x squared. And you can even cancel them out if you want. You can cross them off so you know you're not grabbing it again. Now I have a 5x and a negative 5x. Well, if we add those together, we know that would become 0. So we just leave that alone. And then negative 6 plus 6. Again, negative 6 plus 6, that's a 0. So when we're done, we're going to have just x squared for our new function. In number 2, f minus g. So I'm going to do the same thing. I'm not going to write the first step. So we have f. Now remember, we got to keep these in order. So if I had this x squared by itself, remember I'm taking it away from f. So there is no squared term here. So this is going to become a negative x squared. And then we have a 5x minus negative 5. So that's actually adding. So we have a positive 10x. And then negative 6 minus 6 again. That's going to be a negative 12. So that's why order of the functions is super important, because if we did g minus f, it'd be something completely different. Example 3. We want to multiply a function by a scalar multiplier. So this 3 out front, we're multiplying to m of x. So we look at what m of x is, and we are multiplying. And again, you might skip this step, but just to start, I'm going to write it. So 3 times the entire function, m. So I'm going to put m in parentheses anytime I multiply, because I want to make sure I distribute and hit all my terms. So we end up with, once we multiply 3 in, we're going to get 12x squared. 3 times 3x is 9x. Oh, that was bad. Sorry about that. Again, it's really hard writing with a mouse. 3 times negative 5 is negative 15. And then we're done. So we just scaled it by a factor of 3. In B, we have a negative 2 as a scalar, and we're multiplying h. So we can skip that first step if you want. So we're going to multiply negative 2 into all the terms of function h, which there's only 2 of them. So negative 2 times 3x cubed is going to give us a negative 6x cubed. Negative 2 times negative 1 is a positive 2, and that's our function. So we'll go ahead and pause, do the checkpoints, and I'll go over them. So 5 times h. 5 times h, so we're just multiplying 5 into all the terms. 5 times 3x cubed is 15x cubed. And then 5 times negative 1 would give us a negative 5. Okay, negative 3 times mx. So again, we're going to multiply all the terms by negative 3. So negative 3 times 4 is negative 12x squared. Negative 3 times 3, and negative 3 times negative 5 is 15. Okay. Example 4, and we're almost done. So give us a function A, a function B, and a function C, and perform the following operations, and then simplify. So 3 times A, again, this is a scalar multiplication. We just take the 3 and we multiply all the terms of A, so I'm going to do that. So 3 times 5x squared is 15x squared. 3 times x, and then 3 times 3. And now we're adding 2 times c. So we look at function c, we have 2 terms there, we're going to multiply them by 2. So 2 times 8x is 16x, and then 2 times negative 4 is negative 8. Now once we've done the scalar multiplication, now we can add. So same thing, we need to follow order of operations, just like any other time we're dealing with numbers. So we have a squared term, and then 2 x terms, so 3x and 16x. That give us 19x. And then 9 and negative 8. So that should be a positive 1. So this is our new function. Part B, b of x minus 4a of x. So b, we can just write b. So 4x cubed minus 5x squared minus 9x plus 1. Now we're subtracting 4 times a. So the way that I like to do this is I'm thinking I'm multiplying a by negative 4. So I'm looking at all the terms in a, and I'm just going to multiply by negative 4. Saves time, saves a step or two. So negative 4 times 5x squared is going to be a negative 20x squared. Negative 4 times x is negative 4x. And then negative 4 times 3. Oops. Yeah, negative 4 times 3 is negative 12. So once we've done this, we're going to combine like terms, because I've already dealt with the negative. I multiplied by that negative 4. So now we're just combining like terms. So there's only one cubed term, so that just drops down. And now I have a negative 5x squared and a negative 20x squared. So put those together. That gives us a negative 25x squared. Looking for x's, so I have negative 9x and negative 4x. Put those together and we get negative 13x. And now my constants. So I have a positive 1 and a negative 12. So that would be negative 11. So we're all done. So if you do it in that order, from high exponents to the lowest to a constant, your final answer is going to be in standard form, which means highest exponent first and descending. So go ahead and pause, do the checkpoint, and then I'll go through these with you. All right, first checkpoint, ax minus bx plus 3c. I gotta scroll up, see the functions here. So a, I'm just gonna write a. And some of you are gonna be able to do all of these steps in your head and write a final answer, which I am completely fine with. But till you get really good, I would highly suggest writing out all of these steps. So negative bx. So I'm subtracting bx, or I can think negative bx. So all I want to do is multiply all my terms by -1. So if I do that, that just changes all the signs of b. So b would be a positive 4x cubed plus 5x squared plus 9x minus 1. And then we're adding on 3 times c. So we're just multiplying all the terms in c by 3. So 3 times 8. That gives us a positive 24x. 3 times -4, that would be -12. The same thing that we did in the examples, we're going to simplify. So combining any like terms, so I'm looking for the highest exponent, which is a cube. So I want to write that first. There's only one of them. So 4x cubed. And like I said kind of earlier, you can cross these off just so you're not getting confused. So now I have a 5x squared and then another 5x squared. So if we put those together, we get 10x squareds. Now I'm looking for x's, so I have an x and a 9x. So if I put those, that's 10x, and then I have a 24x. So 10x and 24x is 34x. And then constant, so I have a 3. I have a -1. So put those together, I get 2. And then a -12. So 2 minus 12 would be -10. And that's it. And then final one. So c of x is first, so I write that. So 8x minus 4 minus 2 times a. So again, we're going to multiply a, function a, by -2. So -2 times 5 is -10x squared. -2 times x is -2x. And -2 times 3, -6. And now I can write b. So b is -4x cubed minus 5x squared minus 9x plus 1. Now we're looking for like terms, high to low. Again, there's only one cubed. And then we have 2 squared terms, -10 and a -5. That'd be -15. And then x's, we have a 8x minus 2x, so that would be 6x, minus 9x, so that would be -3x. Now looking for constants, we have a -4 minus 6, so that'd be -10 plus 1, so -9. And that's it. That completes section 2.